Hey friends, today we are going to see the iterative post-order traversal algorithm for a binary tree. So let's see. See, this is the binary tree. So let's first print the post-order traversal for this binary tree. So let's start. So we'll start at the root C, A, then go to the left B, C, D and again return. So the first element in the post order is D, then C, then visit B, then K, E, this is the last visit to E, so print E, then G, F, then K, then B, then N, Q, P, M, A. So N, Q, P, M, A. So this is the post order traversal. So if you are wondering that how I printed this post order traversal using a shortcut trick, then you should watch my video on shortcut trick to post order traversal, for which I have mentioned the link in the description below. So now let's go for the iterative post order traversal algorithm. So this is the algorithm here, and by using this algorithm we will find out the post order traversal. So see, the first statement is the while loop. So the condition is always true inside this while loop, because this while loop will trace every node in this binary tree. So this while loop is for this binary tree. So let's go inside now. There is an if condition, that is if P. So what is P? P is the pointer pointing to a node in a binary tree. So P always points to the current node. Okay. So whatever is the current node, for that we are using pointer P. So for now P will point to the root of the binary tree, because we will always start from the root of a binary tree. Now this pointer P will be passed as a parameter to this function. So suppose this whole code is written inside a function named fun, that is function, and the parameter is P. Okay. So see, inside this function, this is the code written. This is the algorithm inside this function. Okay, and P is passed as a parameter to this function, and then we are using this P as the current node. Okay, so now let's check here. See, at first P points to the root of the binary tree. So this condition is satisfied because P exists here. So if P is true now, so we will go inside this if block. Now push P. So by the command push, you must know that we are going to use here a stack. Okay. So inside this stack you have to push the current node. So that means whenever you are visiting a node, you have to push the node and then you have to go to the left child of the node. So P is equal to P points left. That is written here. See, push current node and go to left child. So see here, you have pushed A and then you have to go to the left child of A. So now P points to B, that is the left child of A. Okay. So see here, this is the if condition, and for this if condition, this else is there. So this else is for this if. Okay, this if and this else. So now this else starts here and ends here. Okay, so you can judge here, if this condition, that is if P is satisfied, then we will not go inside this block, because this is the else block for this if. So this block will not be executed if this if condition is satisfied. Okay, so see here, now as the if condition is satisfied, this block will not be executed, and we will go to the next iteration of the while loop. This is the outer while. Okay, so see, we will go to the next iteration. Now Again in the next iteration check if P. So now P points to B, so P exists. So this if condition is satisfied and we will go inside this block. So push P and go to the left of the current node. So see, push P, that is the node B, and go to the left. Now P points to C. Again go to the next iteration. Again C exists. So push C and go to the next left child of C. So now again the next iteration of while, in the next iteration of while if P means that is D, so node exists. So push D and go to the left child of D, so that is null. So now P points to null. So as P points to null, now see in the next iteration of this while when we check if P, so this condition is not satisfied, so this condition fails, and then we go inside this else block. So now this block will be executed. Okay, so see inside this block the first condition is to check whether all nodes are over or not, means whether the stack is empty or not. So this is the breaking condition for this while. That means this is the breaking condition for this function, because inside this function this while loop is there. This is the main while loop, and if this while loop breaks, then we come out of this function. That means all the nodes in this binary tree are processed. The nodes are over and the post order is printed and our job is done. So if the stack empty condition is satisfied at any point, then we break, and that means that all nodes in the binary tree are over. Okay, so here now let's check if stack is empty. No, stack is not empty. There are 4 elements in the stack. So this condition is not satisfied. So we go in else. See, this else is for this if, right? This is the if and this is the else, and this is the else block. I will mark it. Just see, this is the else block. So this else block starts here and ends here. Okay, so inside this else these conditions are there, and I have numbered the conditions. So as the node in this binary tree comes across any condition, I will number that condition here. Means these are different cases in this algorithm. So whatever the case is satisfied for a node in a binary tree, I will number that here, so that you can easily understand that which case was satisfied for which node, right? So now check in the else block if top points right equal to null. So what is the top node of the stack now? See, the top node of the stack is D. So the node D is here. So we will check whether the right child of the top node is null, and if the right child is null, then what we do? We pop that node and we print that node. Okay, so what is the meaning of these two statements here? See, I will tell you the meaning. See, as you know, for a post order traversal, here if there is a node which is called as parent and there is a left child and right child, then the post order traversal is printed as left child first, then right child, and then the parent. Okay, left child, right child, and parent. So that means for post order traversal, for a root or for a parent, first the left child is processed, then the right child is processed, and then at last the parent is processed. Okay, so see here, for node D the left child is null, so the left child is processed. Now see, where the left child was processed? Left child was processed in this if block. How it was processed? See, P is null, so the left child is null. Okay, so as P is null, so we come to the conclusion that left subtree is null. See, LS means left subtree. So as P is null, we come to the conclusion that left subtree of node D, means the top node of stack, is null. So there is no need to process, so we consider it as processed. Okay, so left child is null, so we go in else block and we check for the right child. So as left child is over, now check for the right child. So if the right child is also null, so if the right child here is also null, then that means the left and the right child are processed. So finally we come to the parent, and parent is at the top of the stack. Automatically the construction of the stack happens in a way such that the top of the stack contains the parent, right? So for that parent we check left subtree, then right subtree, and as the left subtree and right subtree are null, we pop that parent and we print that parent. So let's pop D and print D. Okay, so this is the case. So the first case is satisfied for node D. So left subtree is over, right subtree is over, and at last parent is processed, means that is printed. Okay, now let's go to this condition. See, this block of code I will explain it later. So for whatever node this third case is satisfied, this case number 3 is satisfied for some node in this binary tree. So when we come to that node, I will explain you this block. Okay, for now I will skip this block. So now after you pop and print, directly come out of this if block and go to the next if block. So this is one if block and this is the next if block. This is the second if block, and these two if blocks are inside this main else. See, are inside this main else. Okay, inside this else these two if sequential blocks are there, this if and then this if. So for every node these two ifs will be checked. So now check if stack is not empty. So whether stack is empty now? No, it is not empty. So as it is not empty, this if is satisfied and we assign P to the right child of top node. So what is the top node now? Top node is the node C. So you can look here, as the node D is processed now, we are finished here. So now we turn to the parent of D. So we turn to the parent of D now. So what is the parent of D? That is C. That is the top of the stack. So you can look here, all the all the left children are stacked here. So first A is there, then B is there, then C is there, then it was D. So now D is processed, now is the turn for C. So for C, for node C, as D is processed, that means the left subtree is processed. Now you have to go for the right subtree of that node. See, as the left subtree is processed, let's check the right subtree now. That is why we are writing here. Now P will point to the right subtree of the top node. Okay, so let's go to the right subtree now. Now P is equal to the right subtree, but the right subtree is null, means the right child is null. So P points to null. So see, we will not go inside this else because this if condition is satisfied, so we will not go inside this else. So as this else is now over and this else is also over, let's go to the next iteration now. So for the next iteration, while 1, see inside this while 1, here is the condition if P, but P is null now. So this block is not satisfied and we go inside the else. If stack is empty, no, the stack is not empty. So let's go inside the else for this if. So check, if top points right equal to null. So what is the top node now? Top node is C. So check. So as the top node is C and its right is null, so here is that condition to check whether the right is null, and if it is null then just pop that node and print that node. So right is null, so we pop C and print C. Now after you print C, just skip this block for now and directly go to the next if. So whether stack is empty? No, stack is not empty. So go to the top element of the stack and go to the right child. So what is the top element of the stack is B. So see, for B the left subtree is processed now. Okay, this is the left subtree for B which is now processed. So go to the right subtree. So that is written here, P is equal to top points right. So P points to the node K, that is the right subtree of B. Now as now P points to some node, so in the next iteration P is having some value. Now this if condition will check, if P points to K, then whether the left subtree of K is null or not. So see, check if P, so yes, K exists. So if K exists, then push K and now go to that left subtree. Okay, so go to that left subtree and check whether the left subtree exists or not. So now P points to E. Okay, so as this if condition is checked, we will not go inside this else and we will directly go to the next iteration. Now P points to E. So if P is satisfied, so push E and go to the left child of E. So now P points to null. Now the left subtree for E does not exist. So in the next iteration of while, check if null means if P and P is null. So this if block will not be executed and we will go inside this else. So inside this else, check whether stack is empty. No, it is not empty. Now go in else for this if. So check if top points right equal to null. So for node E, we came to know that the left subtree is null. Now our duty is to check whether the right subtree is null or not. So check whether right subtree is null. Yes, it is null. We have checked here top points right equal to null. Yes, it is null. So if it is null, obviously the left subtree is over, the right subtree is over now. So it is the time to print the parent. See, left subtree, right subtree, then the parent. So it is the time to process the parent and print the parent. So pop that element from the stack, that is E, that is the parent, and print that element. So we have printed that element. Now go to the next if block. So stack is not empty, so go to the top points right. Okay, so what is the top element now? That is K. So for node K, the left subtree is over, so go to the right subtree of K. So for that, P will now point to the right subtree of K. So right subtree of K is F, means the right child is F. So P points to F now. So let's go to the next iteration. If P is satisfied, so we have to push P and go to the left child of P. Okay, so push F here because P points to F and go to the left child of F. So let's go to the left child of F, that is null. So now P points to null. So in the next iteration now, if P condition is not satisfied and we go in else block. So inside else you check whether stack is empty. No, it is not empty. So go in else here. So if top points right equal to null. So see, for node F here, the left subtree checked, it is null. So now your duty is to check the right subtree, whether it is null or not. So see, if top points right is equal to null, this condition is not satisfied because the right subtree of F is not null. There are nodes in the right subtree. So this condition is not satisfied, so we go in next if condition. So if stack is not empty, see, stack is not empty, so this condition is satisfied. So here P is equal to top points right. So as the right subtree is not null, let's go to that right subtree. So now P will point to the right child of top node of the stack, that is F. So now P points to G. Okay, so now as P points to G, in the next iteration, if P condition is satisfied, so push P and go to the left child. So G is pushed in the stack and go to the left child of G, so that is null. So now P points to null. So in the next iteration, if P condition is not satisfied, and we go in else block, and in else block we check whether stack is empty. This condition is not satisfied, so we go in this else and check whether the right subtree of G is null or not. See, for G the left subtree is null, so you have to check now whether right subtree is also null or not. Yes, it is also null. The right subtree is also null. So as the left subtree is processed, right subtree is processed. Now let's process the parent. So P is equal to pop and print that parent. So pop G and print G. Okay. So now let's go to the next condition. Now in this case, this if condition is satisfied. So see, if P equal to top points right. So now as you know, when we pop G, here we pop G and print G. Okay, so we have popped G and printed G. So P is pointing to G now. So P is pointing to G. Okay, so before these statements we popped a node from the top of the stack and we printed that node, and that node was G. So P now points to G. So see, as P points to G, check whether P equal to top points right. So what is the top node of stack? That node is F. So the top node of stack is F, and we are checking whether the right child of F, see, whether the right child of F is P, means P is now G. So whether G is equal to right child of F. Yes, G is the right child of F. That means what exactly we are checking here is that whether G itself is the right child of its parent or not. Means here we are checking whether this node itself is the right child of its parent, and if it is the right child of its parent, that means this is the right subtree of the parent. Okay, and if this is the right subtree of the parent, that means as G is printed, so the right subtree is also processed. So see here, for F the left subtree was processed and the right subtree is also processed, but that is detected when we find out that G is the right child of F. Okay, so as right subtree is also processed, now is the time to process the parent. So let's go inside this if block. So inside the if block we print the data of the top node. So that top node is F. So you have to print F and pop it. Okay, so see, we have popped F. Now again you have to check whether F was the right child of its parent or not. Okay, so see here, oh I'm sorry, actually there is just one change here, sorry. See here, it should be while and you should assign the popped node to P. Okay, so consider this change here. So this is the while loop. So now see, after you pop F, P is assigned to F, means P now points to F. Now for node F, again we will check whether that node F was also the right child of some node, means its parent. So whether F was the right child of its parent, yes. So that is checked here. See, while P equal to top points right. So what is the top node here? K. So for node K, the right child is F. So yes, P is equal to top points right. Okay, means F equal to the right child of K. So K is printed here and then it is popped. Okay, so now K is popped and P will be assigned to the popped node, that is K. So now P points to K, right? So now again check, while P equal to top points right, means we check whether K itself was the right child of some node, means its parent. Yes, it was the right child of its parent. So see here, P equal to top points right. So what is the top node here? B. So right child of B is K. So this condition is again satisfied. So what we do? We print that top node. So see here, we print that node and we pop that node. So B is popped now. Now P will point to the popped node. See here, P will now point to the popped node. So now again check whether P was the right child of its parent. So see here, in the next iteration we again check whether P equal to top points right. Now what is the top node? Top node is A. So top points right is M, but P points to B. So whether B is equal to A points right? No, they are not equal, because right child of A is M. So B is not equal to A points right. So we break this while loop and we come out of this while loop and we come out of this if block, and next we go to the sequential if block. So this is the second if block. So now again check whether stack is empty. No, the stack is not yet empty. So P is equal to top points right. So see here, the total left side of A is finished. The total left subtree for node A is finished. So now we go to the right subtree of A, that is the right child of A. So top points right. So now P points to M here. Okay, and we will again evaluate the code for this subtree, right? So let's do it fast now. So see, P points to M. So in the next iteration, if P is satisfied, so M is pushed into the stack and we move to the left child of M, that is N. So again in the next iteration, N exists, so N is pushed into the stack and we go to the left of N, that is null. See, left of N is null, so P points to null. So in the next iteration, this if is not satisfied, we check whether the stack is empty, then we go and check whether top points right is null. Yes, the top points right is null because the right child for N is null. So as right is also null, we pop and print N. So pop N and print N, right? So now check whether P equal to top points right. See, top node is M. So the right child of M is P. I will say it as the P node. Okay. Just for avoiding the confusion of this P and this P, I will say it as the P node. So the right child of M is P node. So P equal to P node. See, right now P points to N. Okay. So obviously N is not equal to P node. Okay. So this while condition is not satisfied. Here you can see. See, in this subtree, I never shown you this while condition, but now here you can see why this while condition does not satisfy in any other cases. Okay, so this while condition is not satisfied here because the right child of M is P node and right now P points to N. Okay, so let's go to the next if condition. So stack is not yet empty, so P is equal to top points right. So for node M, the left subtree is over because N is printed. So now let's go to the right subtree. So that is the top points right. So now P points to P node. Okay. So when P points to P node, let's go to the next iteration. If P, yes, P node exists. So push P node. So push P node and go to the left child. So again go to the left child. So for the left child, that is q. Again in the next iteration the left child exists, so push q and go to the left child, so that is null. So as left child null, and again in the next iteration we find out the right child is also null, so we pop q and we print q, right? Again we check this while condition and we don't get that while condition satisfied because p points to q and right child of p node is null. Okay, so again in the next if p points to null because top points right is null, so now p points to null. So in the next iteration of while, if p is not satisfied, we go in else, and inside this else we check whether top points right is equal to null, and the top node is p node now, and for p node, yes, the right is null, so we pop p node and we printed p node. So let's go to the while condition now. So see whether p is equal to top points right. What is at the top? M is at the top, so top points right is p node, and right now p also pointing to p node, so p is equal to p node because see top node is m, so m points right is p node, the right child of m is p node, and p also points to p node, so p is equal to p node. So that means now you have to print the top node, so that is m, so m is printed and then popped. Okay, so now p points to m. Okay, now again let's check whether m is the right child of its parent. Yes, it is the right child of its parent. So check whether p is equal to top points right. Yes, the top of the stack is a, and a points right is m, so m is equal to a points right. Okay, so that condition is satisfied and we print a and we pop a from the stack. Now after we pop a from the stack, now p points to a. Okay, so now as p points to a, when we again go in this while condition, see here we check whether p is equal to top points right. So now p is a, but the top of the stack does not exist. Okay, so as it does not exist, it will give an exception. So there will be an exception in your program in this case. So for avoiding this exception, after this p is equal to pop statement, you have to include one statement here. Okay, see this will close here, and after this p is equal to pop, here you have to insert a statement, and that statement is if check whether stack is empty or not. Okay, so see if stack is empty, then you have to break. So this breaking condition you have to include it here as well, because in this while loop, if all these nodes are over, then this stack empty condition will be useful to come out of this while loop. Okay, so that is the case. Now after you come here and check whether stack is empty or not, so see here there will be no problem because here we have already checked. Then again in this else we will go and p will be null. So in the next iteration, if p will be failed, and we will come in else, and here stack empty will be checked, and we will break from the outer while. Okay, we will break from the outer while, this while, and we will come out of this function. So in this way the iterative post order traversal is printed. As we break, we know that all the nodes in the binary tree are over, and the job of printing post order traversal is done. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.